Humanity has gazed at the sky for thousands of years, wondering, is there anyone out there? From the time we first etched stars onto stone to peering into the depths of space with telescopes, this question has never left us. But today is different. It's no longer just daydreaming. Now we know that the Milky Way, with hundreds of billions of stars, is an endless ocean. Many of these stars could host planets where life might have formed. Some of these worlds are so similar to Earth that they make us think perhaps right now, just a few dozen light years away, beings are looking at their own sky and asking the same question. Is there anyone out there? In this video from Astreyon, we're diving right into that question. We're going to visit planets that scientists have pinned their highest hopes on for life beyond Earth. Let's start by tackling the immense scale of the universe, because it's this vastness that makes everything so fascinating. Our own Milky Way, according to the latest estimates up to September 2025, has between 200 to 400 billion stars, a number updated with data from the Gaia telescope and advanced models. And as of this date, over 5,989 exoplanets have been confirmed, with thousands more candidates awaiting review. Interestingly, about 20% of Sun-like stars have an Earth-like planet in the habitable zone, where water can remain liquid and life might form. Telescopes like Kepler and TESS have shown that over 60% of discovered planets are smaller than Neptune, and many have potential for simple life. These stats paint the universe as an ocean full of potential islands, where each island could have its own story. Let's focus on the planets that are truly promising. Places where scientists have invested heavily because they've shown signs of Earth-like conditions. Starting with the closest one, Proxima b. This rocky planet, just 4.2 light-years away, is about Earth's size and sits in a zone where water could be liquid. But 2025 updates reveal big challenges like intense UV radiation, which could destroy atmospheres, and strong stellar winds that might thin the air. Still, new data from the NIRPS instrument, a precise spectrograph for measuring star movements and confirming planets, has confirmed its existence and suggests possible subsurface oceans where life could hide from the radiation. This planet is like a mysterious neighbor who opens the door but keeps the inside dark, forcing us to ask, can life survive in such harsh conditions? Even more intriguing, in 2025, new evidence emerged for another planet around a Sun-like star that might be even closer to habitable conditions. Now, if Proxima b was interesting, check out the TRAPPIST-1 System, a family of 7 Earth-like planets orbiting a small red star. These planets are close to Earth's size, and almost all are in potentially temperate zones, but 3 are in a particularly suitable region. James Webb data shows that TRAPPIST-1d lacks a thick, Earth-like atmosphere and might be dry. New 3D models suggest atmospheres could exist, but with limitations for life. This system, with its closely packed planets, acts like a natural laboratory where stellar winds could transfer materials between worlds and perhaps spread life. But that closeness also raises the risk of atmospheric destruction. The excitement is, if one has life, it might spread to the others, and recent studies suggest the atmospheres could be suitable for simple life, or perhaps life beyond our imagination. But on the other side, there's a planet some call Earth 2.0, Kepler 452b. This planet is slightly larger than Earth, with a sun-like star, and it's in the habitable zone. 2025 studies confirm a rocky surface with a potentially thick atmosphere, and its older age provides time for life to evolve. It might have a dense atmosphere, liquid water, and even active volcanoes, all aiding life cycles. This planet is like an older cousin with plenty of stories to tell, holding potential for complex ecosystems. But models show if CO2, the gas that traps heat, is low, it might be cooler than ideal. And LHS 1140b, one of the best candidates for liquid water. Slightly larger than Earth, with a thick atmosphere that retains heat, with an N2 or CO2 atmosphere, and even deep oceans. This planet, like a hidden island in the cosmic ocean, amps up the excitement because it might have surface liquid water, and new research suggests its internal composition is suitable for retaining vital gases. Now take a deep breath, because we're reaching a peak that sparked heated debates. K2-18b. This planet, larger than Earth, has a thick hydrogen atmosphere with possible oceans beneath. Initial detection of DMS, dimethyl sulfide, a molecule produced on Earth by living things like plankton, was in 2023, but in April 2025, teams reported DMS or DMDS, a similar molecule with moderate confidence. Though July studies showed the evidence is weak and could come from non-biological processes like simple chemical reactions. Also, new research indicates it might have methane and carbon dioxide atmospheres, but without water vapor, suggesting subsurface oceans but not necessarily life. What do you think? Are these molecules from microbes and living beings or just cosmic chemistry? Microscopic life, like bacteria that survive in extreme conditions, is probably the most common form, a foundation for more complex things. But the rare Earth hypothesis, the idea that complex life like animals or intelligence is very rare because it requires a specific combination of factors such as a large moon for axial stability, a strong magnetic field for atmospheric protection, and a calm geological history without major catastrophes, suggests that even if simple life is abundant in the universe, advanced life might only happen on planets like Earth. This hypothesis, proposed by scientists like Peter Ward and Don Brownlee, argues that Earth is a rare exception because factors like galactic position, far from the center to avoid dangerous radiation, and stellar evolution must align precisely. Critics say it overlooks life different from Earth's type, but 2025 studies still support it because we have no direct evidence of complex life out there. However, we must keep in mind that the universe is far too vast and diverse to be judged solely by Earth's example. Life may exist on planets and in environments completely different from our own, taking forms based on conditions and principles unlike those on Earth. forms we have no direct knowledge of yet. This idea leads us to the Fermi paradox, the famous question from Enrico Fermi. If life is so abundant, where is everybody? One intriguing theory is the dark forest hypothesis, the idea that the universe is like a dangerous forest where civilizations hide to avoid destruction because any contact could be hostile and resources are limited. According to this, advanced civilizations deliberately stay quiet to remain unseen, unsure if others are friends or foes. Other theories like the Great Filter, a barrier that stops civilizations, such as nuclear war or climate change, or that civilizations self-destruct early, are also proposed. Perhaps civilizations focus on sustainability instead of expansion, like living without large technological footprints. These contradictions keep humanity engaged. Should we shout out or stay silent? If we ever find other beings, will we still see ourselves as unique or part of a bigger cosmic story? Let's step back from these deep discussions and return to our own solar system, where the signs are more tangible and we can explore directly. Europa, Jupiter's icy moon, is one of the best places to search for life in the solar system. Beneath its cracked, frozen crust lies a vast ocean with twice the volume of Earth's waters. Heat from Jupiter's gravitational pull could warm the interior, creating environments like hydrothermal vents on Earth, places where microbes thrive without sunlight. Europa's icy surface is constantly changing and forms compounds like peroxide, materials that, if they enter the ocean, could provide chemical energy for life. To probe these mysteries, NASA has prepared tools like the REASON radar for the Europa Clipper mission, which will examine ice layers and their connection to the ocean. Though recent studies say the ocean floor might be less active, even a little energy could suffice for simple microbes. Europa is like a hidden world, a massive ocean concealed under a layer of ice with chemical compounds and energy that might create a suitable environment for life. Enceladus, Saturn's small but astonishing moon, is one of the most exciting places to search for life beyond Earth. Its surface is frozen and white like a snowball, but from cracks near the South Pole, massive plumes of water and organic particles shoot into space, as if the moon itself is tossing its clues toward us. Behind this ice lies a vast ocean that's slightly alkaline, with a pH between 10 and 11.6 according to 2025 findings, but still could be suitable for microbes. Enceladus doesn't just have water, it has energy too. Cosmic rays hitting the ice create chemical reactions, producing something like food for potential microbes. Even if its ocean is layered and separated, the plumes deliver internal materials directly to us. This has led some scientists to propose controversial ideas like injecting Earth microbes to test the environment's viability, though contamination risks have sparked strong opposition. What makes Enceladus even more special is that we don't need to drill kilometers into the ice to study it. A spacecraft can just fly through the plumes and collect samples. That's why future missions for close flybys and direct plume sampling are under consideration. Perhaps these plumes, where water and organics spill directly into space, will give us the first definitive sign of extraterrestrial life. And it's this hope that turns Enceladus into one of humanity's most thrilling future destinations. Titan, Saturn's largest moon, is a wondrous and strangely alien world. This moon has a thick, orange-hued atmosphere and is the only place in the solar system, besides Earth, with lakes and rivers on its surface. But unlike Earth, these lakes are filled with liquid methane and ethane, substances that behave like water in Titan's extreme cold. This unique environment triggers chemical cycles reminiscent of early Earth when life was just forming. Scientists even imagine that in Titan's methane lakes, simple cell-like structures called vesicles could form, tiny bubbles that might one day lay the foundation for a different kind of life. Meanwhile, recent examinations indicate few river deltas on Titan, which could mean less surface activity. Still, the presence of organics and weird methane cycles is enough to make Titan one of the best natural labs for understanding how life might arise in the universe. In the coming decades, missions are on the way that could change our view of the universe forever. One of the most important is the Habitable Worlds Observatory, HWO, NASA's new space telescope, set to launch around 2040. This telescope plans to directly image at least 25 Earth-like planets and analyze their atmospheres for signs of life, like biosignature molecules. HWO is essentially the successor to Hubble and James Webb with far more advanced tech. Another major project, LUVOIR, had its final report published in 2025 with parts transferred to HWO. LUVOIR focused on ultraviolet and infrared light, as these wavelengths are crucial for detecting biological traces in planetary atmospheres. Combining these ideas and technologies will push humanity to the brink of a major discovery, finding the first real signs of extraterrestrial life. And this is where the big questions return. Are these molecules, these hidden oceans, and these strange worlds really signs of life? Or does the universe have even more secrets we've only glimpsed the tip of? Perhaps the answer to the Fermi paradox. Why, with all these stars and planets, we haven't seen signs of other civilizations, will become clear sooner than we think. What do you think? Will we soon discover we're not alone? Share your thoughts in the comments and subscribe to Astreyon for more amazing discoveries. Thanks for your attention.